Hey guys, welcome to episode 1 and season 1 of Quantum Demons, and get ready to explore the demonic nature of the undiscovered scientific field of quantum mechanics. In this channel, we will attempt to fully uncover the mysteries in the quantum world with different series and episodes. The majority of the time, I will send out a poll so you guys can tell me what I can start to uncover. In this season, we will work to understand how to design qubits across different paradigms. Specifically, in this video, I will cover the branches of particles to really set us up for success regarding the wackiness of the quantum field. The first step of understanding the coolness of this topic is through atomic structure and particle motion. I'll cover the history of these particles, specifically electrons, as they are one of the most important factors in quantum mechanics. I know that this is very relatable, but we have all seen this image as a second and third grader of a molecule, and we all thought it was the coolest thing ever. We thought we were Albert Einstein. But really, the idea is very simple. The nucleus inside over here is this is the nucleus, and the nucleus is made up of protons and neutrons. So, let's say we have a proton. A proton is a positive charged particle. So this is positive and it is a proton. Now, the nucleus is also made of neutrons. So we have neutrons, and these are neutral charged particles. We'll say plus minus as neutral. Now, you need to understand that protons and neutrons are just normal particles, and there are subatomic particles further in. So, inside protons and neutrons, we also have quarks. Quarks are special subatomic particles that actually allow a proton and neutron to be a proton and a neutron. Now, these quarks are then linked up with gluons. So, let's say we have one quark over here, this red dot, and then we have another quark over here. So then, the quark is pulled together like glue, and that glue type link is called a gluon. So this is basically the atomic structure. Now, these white orbital looking shapes over there, they are where the electrons live. Now, there are several different types of orbitals, and honestly, scientists still can't figure out a good way to figure out how many electrons are in a molecule. So for this reason, they have to predict using orbitals because orbitals are like the area where electrons could be. There are several different types of orbitals like p orbitals, d orbitals, but we're not going to get into that in this video. Just understand that this is the area where electrons live. Now, electrons are negative charged particles. These negative charged particles are extremely important as they characterize the whether a molecule is neutral of an element, right? Now, understanding this particle idea and the atomic structure sets us up for quantum mechanics, as there is an idea that a particle can actually exist in two places at once, and that concept is called superposition. And we're going to get into that later. There's also another concept where one particle cannot even see the other particle, it can't even be bonded with another particle, but they still interact with each other, and this is called entanglement. They can be as far apart from each other, but they still interact with each other. So we'll get into that concept in another video as well. So this is the idea of an atom, right? Now, once we understand this, we also have to understand the history. So, long ago, there was a guy named Dalton, and he came up with Dalton's atomic theory. Now, Dalton's atomic theory was very simple. It was essentially telling us that there's indivisibility of matter. All matter is made of extremely small and indivisible particles called atoms. And these particles, all atoms of like a specific element in mass and properties, they're all the same. Now, atoms of different elements have completely different properties and masses. The next law is that compound formation. Atoms of different elements can combine with each other in fixed whole number ratios to form chemical compounds. And the last thing is called the conservation of mass. Atoms cannot be subdivided, created, or destroyed, similar to the conservation of energy. Chemical reactions simply rearrange and combine or separate these atoms. Now that we got Dalton's atomic theory out of the way, let's talk about the nature of electrons. Now, in the discovery, back in 1897, a scientist named J.J. Thomson was messing around with empty glass tubes. He eventually shot electricity through them, creating a mysterious glowing beam. But when he held a magnet close to it, the beam bent. Since it bent away from negative magnets and towards positive ones, he proved something wild. We know that two of the same charged particles repel from each other, and two of the opposite charged particles attract. So, since it bent away from the negative magnet and toward the positive one, he proved something. He proved that this electricity is made up of tiny negative particles, and that is how he knew that the electron was born. But now, here comes, in 1909, Robert Millikan, who wanted to understand how much an electron weighed. He sprayed oil droplets into a chamber and charged them up with X-rays. Then, he turned on an electric grid and tried to float them. By making the oil droplets hover perfectly in midair, he calculated the exact charge of a single electron. And it turns out it was 1,000 times lighter than a hydrogen atom. Now, since we understand how the electron and our discoveries have evolved, we wanted to see how it would interact when the scientists wanted to figure out how it would interact when we fired electrons through two tiny slits. Instead of hitting the wall like bullets, they formed a wave pattern. But when the scientists tried to watch them do it, the electrons magically went back to acting like regular particles. Now, this proved wave-particle duality, the bedrock of quantum physics. So, let me summarize exactly what I said. So now we covered Dalton's atomic theory. Now this just explained the nature of an atom, right? And we already went over that, so that's done. So now we went over cathode rays. Now this discovered the discovery of an electron by the interaction between it and a magnet and how it repelled from a negative side and attracted to the positive side. And this was done by J.J. Thomson. Next, we discovered Robert Millikan oil drop test to figure out the weight of an electron. Weight of an electron. Now this helped us understand how it was 1,000 times lighter than a hydrogen atom. So now we got that out of the way. And we also uncovered how the quantum twist was also involved. We figured out that there was actually a wave and particle interaction between electrons. It helped us prove that because the electrons did not hit the wall like bullets, they instead formed a wave pattern. It helps us prove that particles and waves interact in the same nature. So now we also proved the quantum physics sides of things. Sorry for my not neat handwriting. I am trying to write extremely fast. From this video, I hope you understood how the atomic structure of a molecule and the history of an electron. These were my two goals in this video because it sets us up perfectly for our next video about superposition and entanglement. Thank you.